Hello and welcome back to the Tech Blackboard. Today in part 5 of TP203 exam question and answer series, we are going to cover 15 latest questions. While doing these questions, I will also explain important concepts on NoSQL databases, Azure Data Lake, Azure Storage, redundancy options like LRS, ZRS, GRS, GZRS and much more. Very important video, so watch the video very carefully, grab the concepts, and this will surely help you get good grades in DP203 certificate. And as always friends, if this video adds any value in your learning, please appreciate our efforts by pressing the like button, subscribing to the channel and press that bell icon to receive all the notifications. And friends, so far in this series, we have covered 40 questions in the previous 4 parts. Make sure to watch all of those parts. The links are available in the description box. And friends, along with learning in video mode, we want to help you further in your offline learning as well. And that's why I will share a free PDF file with all the 15 questions covered in this part 5. And for that, you have to give me the correct answers for the question number 45, 50 and 55. All the answers for all these 3 questions are available in this video itself. So let's get started with part 5. So let's begin the part 5 with question number 41. The question says that the open source world offers 4 types of NoSQL databases. Select all the options that are applicable. And please note that each correct selection is worth 1 point. Your options are SQL database, Apache Hadoop, key value store, document database, graph database, column database, Cosmos DB, and the last one is Azure SQL Synapse. The correct answer for this question is option C, option D, option E, and option F. Now let me give you a little bit more detail on each of the correct option. So the key value store, it stores the key values pair of data in a table structure. Coming to the document database, that stores the documents that are tagged with metadata to aid the document searches. Now let's look at the graph database. So the graph database, it helps find the relationship between data points by using a structure that's composed of vertices and edges. And lastly, we have column database. So the column database stores the data based on columns rather than rows. Columns can be defined at query runtime, and that allows flexibility in data that's returned performantly. Now let's move to question number 42. The question says that Azure Databricks is the least expensive choice when you have to store the data, but you don't need to query the data. Is this statement a yes or a no? The correct answer for this statement is no. So what according to you is the correct option where you want to store the data, but you don't want to query it? Let's explore the same in the next question 43. Azure Storage is the least expensive choice when you want to store the data, but you don't need to query it. And this time this is a correct statement. Moving on with question number 44. The question says that the unstructured data is stored in non-relational systems, commonly called as unstructured or NoSQL. And the correct answer for this question is that this is a correct statement. Now looking at the unstructured data, so the examples of unstructured data include binary, audio and image file. Unstructured data is stored in non-relational systems, commonly called as unstructured or NoSQL system. In non-relational systems, the data structure is not defined at the design time and the data typically is loaded in a raw format. The data structure is defined only when the data is read. So always keep in mind this important difference between non-relational database and relational database. In relational database, we create the data structure at the design time. On the other hand, in non-relational or the unstructured or the NoSQL databases, we define the data structure only when we query them. Moving on with question number 45, the question says that you are designing an Azure Stream Analytics job to process incoming events from sensors in retail environment. You need to process the events to produce a running average of shopper counts during the previous 15 minutes, calculated at 5-minute interval. Which type of window should you use? Your options are snapshot, tumbling, hopping or sliding. And the correct answer for this question is option C, hopping window. Let's understand hopping window in a little bit more detail. So unlike tumbling window, hopping windows model scheduled overlapping windows. A hopping window specification consists of three parameters: the time unit, the window size, and the hop size. Additionally, offset size may be used as an optional fourth parameter. Here you can see the Microsoft has given an example where it shows an example every 5 seconds give me the count of tweets over the last 10 seconds. And here you can see this is a quick representation of hopping window. You can also observe how you can use or construct a query when you want to use hopping window. The syntax is also given. You can also check out the arguments. So in arguments, we have day, hour, minute, second, millisecond, or microsecond. Then you can also observe some of the example and time consideration. The link for this important documentation and all the documentation that I will use in part 5 is given in the description box. And now friends, I want your full focus on the next three questions as they are related to a very important concept, Azure storage redundancy, that confuses a lot of people. So let's check out question number 46. So the question says that you are implementing an Azure Data Lake Gen 2 storage account. You need to ensure that the data will be accessible for both read and write operation, even if an entire data center, zonal or non-zonal, becomes unavailable. Which kind of replication would you use for the storage account? And you have to choose the solution with the minimum cost. And your options are locally redundant storage or LRS, zone redundant storage or ZRS, geo-redundant storage GRS, or the last one is geo-zone redundant storage, which is GZRS. Before jumping to the answers, let's first understand what are the keywords given in the question. The first one is this one, where the question clearly says that the both read and write operations should be available even if an entire data center becomes unavailable. And friends, please pay attention that the question categorically says that the data center could be zonal or non-zonal. So this is a very important point that you must keep in mind when answering this question. Now let's first understand each of these options given in the question. And for that, I am here at the Microsoft documentation on Azure Storage Redundancy. Let's check out them one by one. So first one is locally redundant storage, and that copies your data synchronously 3 times within a single physical location in the primary region. And friends, I hope you remember the question mentioned both read and write operations should be available even if the entire data center fails, zonal or non-zonal. And that's why locally redundant storage is out of the scope. Moving on with the zone redundant storage, and this one copies your data synchronously across the 3 Azure availability zones in the primary region. For the application requiring high availability, Microsoft recommends using ZRS in the primary region and also replicating to a secondary region. Now let's understand what is geo-redundant storage. So this one copies your data synchronously 3 times within a single physical location in the primary region using LRS. It then copies your data asynchronously to a single physical location in a secondary region that is hundreds of miles away from the primary region. And then we have geo-zone redundant storage. So this one combines the high availability provided by the redundancy across availability zones with protection from regional outages provided by geo-replication. Data in GZRS storage is copied across 3 availability zones in primary region and is also replicated to a secondary geographic region for protection from regional disasters. Friends, I strongly recommend that you read in detail about all the redundant storage options in Microsoft Azure. Now coming back to the presentation, as we saw in the Microsoft documentation, locally redundant storage is out of question. And now we have to choose from ZRS, GRS or GZRS. And for that, I have come to this Microsoft documentation on bandwidth pricing. And in this documentation, you can see the data transfer rates. So here you can observe that the data transfer rates within the zones is much lower than the data transfer rates within the regions. The correct answer for this question is option B, zone redundant storage or ZRS. I hope you understood the concept of LRS, ZRS, GRS or GZRS. In case you want clarification or you have some doubts around this question, then do let me know in the comment section, or you can also connect with me on Instagram messages. The link for all the social media platform is given in the description box. Now let's jump to question number 47. The question says that you have an Azure Data Lake Storage Gen 2 container that contains 100 TB of data. You need to ensure that the data in the container is available for read workloads in a secondary region even if an outage occurs in the primary region. The solution must be of minimum cost. Which type of data redundancy should you use? Your options are GRS or geo-redundant storage, read access geo-redundant storage, zone redundant storage, or locally redundant storage. And the correct answer for this question is option B, read access geo-redundant storage. Now many of you may argue that why not choose geo-redundant storage or GRS, as this is a much cheaper option. However, you must consider the question says that we must be able to read the workloads in a secondary region even if the outage occurs in the primary region. And because GRS does not initiate an automatic failover, and due to that you won't be able to read the workload unless you do the manual failover. And that's the reason I have chosen RAGRS as the correct answer to this question. Now let's move to question number 48. The question says that you plan to implement an Azure Data Lake Gen 2 storage account. You need to ensure that the data lake will remain available even if a data center fails in the primary Azure region. The solution must minimize the cost. Which type of replication should you use for the storage account? Your options are GRS, GZRS, ZRS, or LRS. The correct answer for this question is option C, zone redundant storage. You can refer the same documentation that we use in question number 46 to read more about all these storage redundancy options. Now let's check out a different kind of question in question number 49. The question says that you need to design an Azure CNAPP Analytics dedicated SQL pool that meets the following requirements. The first requirement is can return an employee record from a given point in time. The second requirement is maintains the latest employee information, and the third one is minimizes query complexity. Then the question says, how should you model the employee data? Your options are as a temporal table, as a SQL graph table, as a degenerate dimension table, or the last option is as a type 2 slowly changing dimension or SCD table. The correct answer for this question is option D. So let's understand what is a type 2 slowly changing dimension. Here on this Microsoft documentation, you can first read about type 1 SCD, and then just below it you can read about type 2 SCD. And the documentation says a type 2 SCD supports versioning of dimension members. Often the source system does not store version, so the data warehouse load process detects and manages changes in the dimension table. In this case, the dimension table must use a surrogate key to provide a unique reference to a version of a dimension member. A great documentation to understand the difference between type 1 and type 2 SCD. The link as usual is provided in the description box. And with that, let's jump to the question number 50. Question says that you have a SQL pool in Azure Synapse that contains a table named dbo.customers. The table contains a column named email. You need to prevent non-administrative users from seeing the full email addresses in the email column. The users must see the values in a format of abc@xxxx.com. What should you use? Your options are from Microsoft SQL Server Management Studio, send an email mask on the email column, or from the Microsoft Azure portal, set a mask on the email column. The third option is from Microsoft SQL Server Management Studio, grant select permission to the users for all the columns in the dbo.customers table except email. Or the last option is from the Azure portal, set a sensitivity classification of confidential for the email column. The correct answer for this question is option B, from the Microsoft Azure portal, set a mask on the email column. And in case you are looking forward for more details on dynamic data masking, then this is the Microsoft documentation. And here the documentation says dynamic data masking helps prevent unauthorized access to sensitive data by enabling customers to designate how much of the sensitive data to reveal with minimal impact on application layer. You can read a lot more about data masking on this documentation. Coming up now is question number 51. The question says you have a SQL pool in Azure Synapse. A user reports that the queries against the pool take longer than expected to complete. You need to add monitoring to the underlying storage to help diagnose the issue. Which two metrics should you monitor? Your options are cache hit percentage, active queries, snapshot storage size, DWU limit, or the last option is cache use percentage. The correct answer for this question is option A, cache hit percentage, and option E, cache used percentage. A little bit more on each of these. First, let's take cache hit percentage, and please understand that cache hits is the sum of all column store segment hits in local SSD cache. And now comes cache use percentage. So cache used is the sum of all the bytes in local SSD cache across all the nodes. Moving on with question number 52. The question says you have a SQL pool in Azure Synapse. You discovered that some of the queries fail or take long time to complete. You need to monitor for transactions that have rolled back. Which dynamic management views should you query? Your options are given here. And the correct answer for this question is option A, sys.dm underscore pdw underscore nodes underscore tran underscore database underscore transaction. Now let's move on with question number 53, and it says that you are designing an Azure Databricks table. The table will ingest an average of 20 million streaming events per day. You need to persist the events in the table for use in incremental load pipeline jobs in Azure Databricks. The solution must minimize storage cost and incremental load times. What should you include in the solution? Your options are partition by date time fields, sync to Azure Queue Storage, include a watermark column, or use a JSON format for physical data storage. And the correct answer for this question is option B, sync to Azure Queue Storage. Adding a little bit more detail on Azure Queue Storage. And friends, here you can see the ABS AQS. ABS means Azure Blob Storage and AQS means Azure Queue Storage. So ABS AQS connector provides an optimized file source that uses Azure Queue Storage to find new files written to an Azure Blob Storage container without repeatedly listing all the files. This provides two advantages. The first one is lower latency. No need to list nested directory structures on ABS, which is slow and resource intensive. The second benefit is lower cost. No more costly list API requests made to ABS. And here is a very important disclaimer on the Databricks ABS AQS. So friends, the Databricks ABS AQS connector is now deprecated. Databricks recommends using autoloader instead. So please keep in mind that though ABS AQS is now deprecated, you might still witness some question around it. However, for all the practical purposes, you should now use autoloader. Quickly moving to question number 54. The question says that you have a partition table in an Azure Synapse Analytics dedicated SQL pool. You need to design queries to maximize the benefits of partition elimination. What should you include in the transaction SQL queries? Your options are join, where, distinct, or group by. The correct answer for this question is option B, where clause. And this is because when you add where clause to your TSQL query, it allows the query optimizer accesses only the relevant partition to satisfy the filter criteria of the query, which is what partition elimination is all about. And that brings us to question number 55, which is the last question for our DP203 exam Q&A series part 5. So let's read the question. The question says that you have an Azure Synapse Analytics dedicated SQL pool that contains a large fact table. The table contains 50 columns and 5 billion rows, and it's a heap. Most queries against the table aggregate values from approximately 100 million rows and return only 2 columns. You discover that the queries against the fact table are very slow. Which type of index should you add to provide the fastest query times? Your options are non-clustered column store, clustered column store, non-clustered, or clustered. And the correct answer for this question is option B, clustered column store. So what is a clustered column store? So clustered column store indexes are one of the most efficient ways you can store your data in dedicated SQL pool. Column store tables won't benefit a query unless the table has more than 60 million rows. And here, my friends, we can very well see that we already have 100 million rows. And that's why the clustered column store type of index fits this business case. So those were the 15 important questions on DP203. I hope you enjoyed the questions and answers as much as I did. I'm looking forward for your feedback on the questions and what are the questions you want me to cover in the upcoming parts. Please share your thoughts in the comment section below. You can also connect with us on the other social media platform like Instagram, Facebook and Twitter. Information for the same is now on your screen and in the description box as well. I will see you in the next video. Till then, stay fit, keep learning and thanks for watching.
If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning and thanks for watching.